Hello everyone, welcome to my channel. If you are new to this channel or you haven't yet subscribed, please support us by subscribing. In this video I have one integral that I would like us to look at. It's the integral of x dx all over 1 plus square root of x plus x. Now how we approach this is by looking at the denominator. Obviously, if you look at the denominator, there is the square root of x there that catches our eye, and therefore we will have to start from there by letting u squared be equal to x, and then replacing x and x up there with u squared. So let's look at the approach now. It's the integral of x dx, dividing this by 1 plus square root of x plus x. And like I said, we're going to let u squared, because of square root there, u squared be equal to x. We're going to obtain equations from here. The first one is to take the positive square root on both sides. On the left, you're going to have u. On the right, you'll have a square root of x. Right, the first one. The second one is to differentiate u implicitly with respect to x. So you're going to get 2u du. On the right, you're going to have dx. Right, now let's transform this integral then. Transforming that integral, we have the integral of, in place of x, we're going to have u squared. And in place of dx, we're going to have 2u du. And in the denominator, we're going to have 1 plus square root of u squared plus u squared. Remember, where there's x, you must put u squared. Now, let's take 2 out because 2 is a constant. So we take 2 out and we say this is equal to u squared times u, it is u cubed. And then we have du. In the denominator, let me rewrite this to u squared plus square root of u squared is u. We're talking about the positive square root there, and then we have plus 1, like this. Let me rewrite this further to 2 times the integral of 1 all over, actually u cubed, integral of u cubed all over u squared plus u plus 1. And I want to multiply this by du, like so. Now, where to from here? Well, if you look at the numerator there, we have u cubed, and in the denominator you have u squared plus u plus 1. This should remind you of the difference of 2 cubes. Let me just remind you there. The difference of 2 cubes, remember, we said when you have, let me use u cubed minus 1. If you factorize this, it's going to be, in the first bracket, the cube root of u cubed is u, the cube root of 1 is 1, and we have minus. In the second bracket, we'll have to take that multiply by itself, is u squared, and then multiply these 2 out, is u. There's a minus sign, so the sign here has to be plus. The signs here must always be different. And then 1 times itself, the answer is 1. Now, if you look at this one here, is what we have in the denominator there. So it means I must create u cubed minus 1 in the numerator as follows, taking us to the next page. So what we have now is, this is going to be equal to, let me move this one down. All right, moving it down, we have 2 times the integral of u cubed. I'm going to say minus 1, but I don't want to change the integral, so I'm going to say plus 1. And we're dividing this by u squared plus u plus 1, and then we have du. Now, the numerator, I'm going to use term-wise division now. Keeping 2 out, we have the integral of, watch this, u cubed minus 1, and I'm dividing this by u squared plus u plus 1, and then times du, like that. But we have plus 1 there, so we have to say plus. And I'm doing this because I'm distributing du here, if you can see what I mean. It will be 1 all over u squared plus u plus 1 du, and then we take the integral of that, then close the bracket there. Right, so what I've done is to take this expression, divide into u cubed minus 1, and then also divide into 1, and then distribute du and the integral there. All right, moving on. So what we have is 2 times this part here. Remember, u cubed minus 1 factorizes like this. So we have u cubed, the integral of u minus 1 in one bracket, the other bracket u squared plus u plus 1, and we're dividing this by u squared plus u plus 1 du. And then we're going to say plus the last part. I'm going to complete the square. I'm going to complete the square of u squared plus u. You will agree with me that we take the coefficient of u, which is 1, we divide it by 2 in step number 1. Step number 2, we square that. The answer is a quarter. And in step number 3, we add. Right, so we're going to have to add this to that term. So we're basically saying u squared plus u plus a quarter. Right, but if you, so this now allows us to factorize this as u plus half or squared, which is a square of a bracketed expression. But if you check outside there, we have 1, so which means we'll have to say 1/4 plus 3/4 because we don't want to change the integral. So it will be the integral of 1 all over, watch this, u squared plus u plus a quarter plus 3/4, and then we have du, like that. Fantastic. Now let me put this in brackets, and you can see that this cancels that. So what we have now is 2 open brackets, the integral of u minus 1, and we have du there, and then we have this part here is going to be plus, allow me to rewrite this as the integral of 1 all over this part here is u plus half or squared, and then I have plus 3/4 outside du, like that. Now this part here, when I write it like this, I need to have a 1 here, so I must factorize this where 3/4 will be my common factor. This part I will have to perform simple integration here. You don't have to distribute du and the integral. We can just do the integration of each term. So this is going to be 2 times u squared all over 2 minus u, if you catch what I mean. And then this is going to be plus this part here. It's going to be the integral of, like I told you, 3/4 is a common factor, and then we're going to say 3/4 into this expression. So it will be u plus half all squared all over 3/4 plus 1, and then du, like that. We have to simplify this part in my next step, page 3. So on page 3, I'm saying that is equal to 2. Let's keep the 2 out for now. 2, we have u squared over 2 minus u, and then I'm going to say plus 3/4. Remember, it's dividing, so we can take it out as 4 over 3, not 3 over 4, 4 over 3. So it's going to be 4 over 3. Let me remove that. We're changing that to 4 over 3 because it's dividing, remember. So we're going to say 4 over 3 times the integral of 1 all over this part here. Now, hope you can see what I'm trying to say. Let me move this one down. This part now has to be changed as follows. The 4 goes up, the 3 comes down. So it's going to be 4 times u plus half all squared over 3 plus 1. And then I have du. Right. Then what do I do next? Well, let me close the bracket there. And I'm going to have to rewrite this term here also. So this part, let me keep the 2 out, times u squared over 2 minus u plus 4 over 3 integral of, watch how I'm going to write this part here, 1 all over. Here I'm going to have to multiply, take 4 inside this, the square. If you agree with me, it's going to be, we have to say 2 times u plus half. This has to be all over square root of 3, and I must say the whole of this squared plus 1 du. Of course, if you take you remove these brackets, that is going to be 4 and that will be 3. We're back there. Now 2 must go in and the 3 must remain the way it is. Let me close that bracket there. So what we have now is 2. We have u squared over 2 minus u plus 4 over 3. And then we have the integral of 1 all over. Watch this now. 2 times u, it's 2u. 2 times half is 1. And I'm going to say over root 3. And this has to be like this squared. We are going to say plus 1. Let me use brackets here now. Square bracket will be critical here so that we understand that this is just one term, all of it. We're basically combining that as our denominator, the whole of that, times du. So now, what next? At this stage, let me close that bracket. At this stage, I'm going to let tan theta be equal to 2u plus 1 over root 3. So let tan theta be equal to 2u plus 1 over root 3. And so from here, we get two equations. The first one is theta is equal to tan inverse of 2u plus 1 over root 3. That's the first one. The second one will be differentiate both sides with respect to u. So it will be implicit because here we have theta. So we're going to say and multiply root 3 on both sides. So it will be root 3. Derivative of this part here is going to be sec squared theta d theta. On the right hand side, you're just going to have 2 du. If you catch what I mean, divide by 2 both sides. We're going to have root 3 over 2 sec squared theta d theta is equal to du. Fantastic. Now that is taken care of. This part here, we're going to replace it with tan. Therefore, that integral, if I can have it in this space here, if I can have it down here, this integral now changes to here 2, and I'm going to say open brackets u squared over 2 minus u plus 4 over 3. And this part now changes to the integral of 1 all over tan squared theta plus 1 times root 3 over 2 sec squared theta d theta. That's how it changes. Now, so what do we do next? Well, we simplify this. Remember, this part here, tan squared plus 1 equals sec squared. So I can actually cancel this one here and that one there. And then take root 3 over 2 out. Coming to page 4. So what do we have on page 4? Let me move this one down. So what we have now on page 4 is the following. When I have 2, I'm going to still keep 2 outside. U squared over 2 minus u plus 4 over 3. The integral of, I'm going to say this, keep that one inside for now because I've already written this part here. So it's going to be root 3 over 2. And then what do we have? D theta. Now this is a constant. We can take it out. So this is going to be 2 times u squared over 2 minus u plus 4 over 3 times root 3 over 2 times the integral of 1 d theta. Now, you'll agree with me that integral of 1 with respect to theta is just theta, and this cancels there 2. And so what do we have now is 2, keep u squared over 2 minus u. And what do we have now here? We're going to have plus 2 root 3 over 3 theta. Remember, the integral of 1 with respect to theta is theta, and I must say plus c now. Distribute the 2. We're going to have u squared minus 2u. Multiply there, it's going to be 4 root 3 over 3 theta plus c. But what is our theta? Our theta, if you agree with me here, our theta is tan inverse of u, 2u plus 1 over root 3. So this is going to be u squared minus 2u plus 4 root 3 over 3 tan inverse of 2u plus 1 over root 3 and then plus c. Now we must go back to our original variable, which is actually x and not u. Going back to page 1. On page 1, what did we have? Here is u. The relationship between u and x is that u equals square root of x. So where there is u, I put square root of x. So what I have now is square root of x has to be squared minus 2 square root of x plus 4 root 3 over 3 tan inverse of 2 square root of x plus 1 over root 3, and then we have to say plus c. Let's simplify this part, taking us to our last step where we write down our final solution. So this is going to be x, if you agree with me, minus 2 root x plus 4 root 3 over 3 tan inverse of what we have, 2 root x plus 1 over root 3, and then we have to say plus c. So this is our final solution to this integral that we have in this video. I'm just going to go on, just going to go through only one today. In this video, I'm not going to look at the second integral. Maybe in the next video, we're going to look at the next one. So this is the integral we have looked at, which involves advanced u-substitution and of course trig substitution coming in as well. All right, if you're new to the channel, like I said at the beginning, support us by subscribing, giving us your feedback. We truly value your feedback. All right, I'll see you in the next one.